Hello student, welcome to my lecture on the paper number 106 complex analysis. In the previous lecture, we have studied harmonic function and its example and conjugate harmonic function and its example. In this lecture, we have studied mapping or transformation and bilinear transformation or Mobius transformation. First definition. If a complex function w is equal to f of z is defined in domain D of the z-plane to each point D, the corresponds of the point W such a function relation is called mapping or transformation. Now let's see the example on this definition transformation. Find the image of 1 less than 2 1 less than x less than 2 under the mapping w is equal to 1 by z. So we see the image of 1 less than x less than 2 in the z plane. So in this figure, in this graph, this is 0 comma 0 and this is x axis and this is y axis. X is equal to 1 is here and this is x is equal to 2 line. We have given 1 less than x less than 2, so cover this area except x is equal to 1 and x is equal to 2. Means x is equal to 1 line and x is equal to 2 બંને લાઈનના વચ્ચેનો આખો રિજિયન કવર થશે પણ બંને લાઈન કવર થશે નહીં. X is equal to 1 and x is equal to 2. Now solution w is equal to u plus iota v is equal to 1 upon z and x is equal z is equal to 1 upon w. So put the value of z is equal to x plus iota y and w is equal to u plus iota v. So ઉપર નીચે u minus iota v વડે multiply કરીએ. So x plus iota y is equal to u minus iota v upon u square plus v square. So here real part is u upon u square plus v square and imaginary part minus v upon u square plus v square. So compare real and imaginary part of this. So we get x is equal to u upon u square plus v square and y is equal to minus v upon u square plus v square. Now here we have given 1 less than x less than 2. So put the value of x. So 1 is less than u upon u square plus v square is less than 2. So 1 is less than u upon u square plus v square. So u square plus v square is less than u. So now u square minus u plus v square is less than 0. So બંને બાજુ 1/4 એડ કરીએ તો અહીંયા સ્ક્વેર 1 u minus 1/2 all square plus v square v minus 0 square is less than 1/2 square. બંને બાજુ 1/4 વડે એડ કર્યા. So here u minus 1/2 square plus v minus 0 square is less than 1/2 square. So center at 1/2 comma 0 and radius r is equal to 1 by 2. Now u upon u square plus v square is less than 2. So u ને આ બાજુ લઈએ તો 2 upon u is greater than 1 upon u square plus v square. So u square plus v square ને આ બાજુ લઈએ તો u square plus v square is greater than u upon 2 plus માં આવશે અને આ બાજુ આવશે તો minus sign આવશે is greater than 0. So here u square plus v square minus u upon 2 is greater than 0. So u square minus u upon 2 બંને બાજુ 1 upon 16 એડ કરીએ. So we get u minus 1 upon 4 whole square plus v square minus 0 whole square is greater than 1 upon 4 whole square. So center at 1 by 4 comma 0 and radius r is equal to 1 by 4. So here this is represent circle center at 1 by 4 comma 0 and radius 1 by 4, and this is greater than sign. So this is represent circle center at 1 by 4 comma 0 radius 1 by 4 and region cover outside of the circle, and this is represent circle center at 1 by 2 comma 0 radius 1 by 2, and this is less than, so this is the region is inside of the circle. So this is 1 by 2 comma 0 center, 1 by 2 radius, and region cover inside of the circle. So this is required region in the W plane. Now we see the next example. Determine and sketch the region x is greater than or equal to 1 under the transformation w is equal to 1 by z. So here w is equal to 1 by z, so z is equal to 1 upon w. First we represent z plane. Here given x is greater than or equal to 1, so region covered in the z plane, x is equal to 1 line and x is greater than or equal to 1, so this line, this region covered in z plane. Now z is equal to 1 upon u plus iota v and z is equal to x plus iota v. So multiply u minus iota v, ઉપર નીચે મલ્ટીપ્લાય કરીએ u minus iota v વડે તો આપણે મળે u minus iota v upon u square plus v square. So here real part is u upon u square plus v square and imaginary part is minus v upon u square plus v square. Compare real and imaginary part, we get x is equal to u upon u square plus v square and y is equal to minus v upon u square plus v square. So here we have given x is greater than or equal to 1. So x is equal to u upon u square plus v square is greater than or equal to 1. So u is greater than or equal to u square plus v square. So u square minus u plus v square is less than or equal to 0. So u minus 1 by 2 whole square plus v minus 0 square is less than 1 by 2 whole square. So here center is 1 by 2 comma 0 and radius 1 by 2, and this is less than or equal to sign. So this is uh, cover the center at 1 by 2 comma 0 and radius 1 by 2 represents circle, and the region is inside of the circle, inside and on the circle and inside the circle. Now the next example, find the sketch the image of the region mod z greater than 1 under the transformation w is equal to 4 into z. So in the z plane mod z is greater than 1. So mod z is equal to mod x plus iota y is greater than 1. So x square plus y square is greater than 1. So x square plus y square represent circle center at 0, 0 and radius 1, and this is greater than sign. So region covered outside of the circle in z plane. And next w is equal to 4 into z. So mod w is equal to 4 into mod z. So mod z is equal to mod w upon 4. Here given mod z is greater than 1, so mod w upon 4 is greater than 1. So mod w is greater than 4. So u square plus v square is greater than 4, and this is represent circle center at 0, 0 and radius 2. R is equal to 2 and region covered outside of the circle. And the next example, find the image of x minus 2 whole square plus y square is equal to 1 under the transformation w is equal to z minus 1 upon z plus 1. So in the z plane x minus 2 whole square plus y square is equal to 1. So center at 2 comma 0 radius 1. So this is represent circle this is x axis and this is y axis, center at 2 comma 0 and radius 1. So this is 1 comma 0. So this is circle center at 2 comma 0 radius 1. Now in the w plane w is equal to z minus 1 upon z plus 1. So multiplying z plus 1 into w into z plus 1 is equal to z minus 1. So wz plus w is equal to z minus 1. So w into z minus z is equal to minus 1 minus w. So common out z. So z into minus 1 plus w is equal to minus 1 minus w. So z is equal to minus 1 minus w upon w minus 1 is equal to minus common out લઈએ તો w plus 1 અને આમાંથી માઇનસ કોમન લઈએ તો 1 minus w. and z conjugate is equal to w conjugate plus 1 upon 1 minus w conjugate. So here x square plus y square is equal to z into z conjugate. This is mod z. So x is equal to z plus z conjugate upon 2. So x minus 2 whole square is equal to, sorry, x minus 2 whole square plus y square is equal to 1. So this is represent mod z minus 2 is equal to 0. Now put the value of z is equal to w plus 1 upon 1 minus w minus 2 is equal to 1. So let LCM is equal to 1 minus w. So w plus 1 minus 2 into 1 minus w. So this is equal to minus 2 minus minus plus 2 w is equal to 1. So this is 3w minus 1 upon 1 minus w is equal to 1. So 3w minus 1 is equal to 1 minus w modulus. Now put the value of w. W is equal to u plus iota v. So u plus iota v, here 3w multiplying 3 into u plus iota v. So this is 3u plus 3 iota v, so plus uh, minus 1, 3w minus 1, so this is minus 1, so 3u minus 1 plus iota 3v is equal to 1 minus minus u minus iota v. So here 1 minus w is equal to u plus iota v, and 1 minus sign लगाड़े तो 1 minus u minus iota v modulus में mod x plus iota y હોય તો એને લખી શકાય x square plus y square. So 3u minus 1 square plus 9v square is equal to 1 minus u square plus v square. So square u 3u minus 1 square is equal to 9u square minus 6u plus 1 plus 9v square is equal to 1 minus 2u plus v square plus u square plus v square. So આખી ટર્મને આ બાજુ લઈએ તો -1 plus 2u minus u square minus v square is equal to 0. So this is 9u square minus u square is equal to 8u square. 9v square minus v square is equal to 8v square minus 6u plus 2u minus 4u, and this is cancel out, is equal to 0. Now divided by 8 we get u square minus u upon 2 plus v square is equal to 0. So u square minus u upon 2 adding 1 upon 16 for this side, we get u minus 1 by 4 whole square plus v square is equal to 1 by 4 whole square. So center at 1 by 4 comma 0 and radius 1 by 4. In the w plane, u minus 1 by 4 square plus v minus 1 by v minus 0 square is equal to 1 upon 4 whole square. So center at 1 by 4 comma 0 and radius 1 by 4. So this is represent circle and region cover on the circle. Now the next topic, bilinear transformation or Mobius transformation. W is equal to f of z, and f of z is equal to az plus b upon cz plus d, where ad minus bc not equal to 0. where A, B, C and D are complex constant, and this is known as bilinear transformation or Mobius transformation, invariant point or fixed point. Fixed point of function w is equal to f of z are points which are mapped onto then self, that is at that is kept fixed under the mapping bilinear transformation satisfy. So self means f of w is equal to z, f of z is equal to z. This is self mapping. Uh, Fixed under the mapping bilinear transformations that is satisfied. So w minus w1 upon w minus w3 into w2 minus w3 upon w2 minus w1 is equal to z minus z1 upon z minus z3 into z2 minus z3 upon z2 minus z1. This is cross ratio or harmonic ratio. અહીંયા આપણે જોઈએ તો w minus w1 w2 w3 upon w minus w3 w2 w1 1 2 3 and અહીંયા ક્રોસમાં 3 2 1. અહીંયા જો w લઈએ તો અહીંયા z લેવાનો, અહીંયા w1 લઈએ તો z1 લેવાનો, w2 લઈએ તો w2 લેવાનું, w3 લઈએ તો z3 લેવાનું. અહીંયા જો w ની જગ્યાએ આપણે w1 લઈએ તો અહીંયા z ની જગ્યાએ z1 લેવાનું. Find the bilinear transformation that maps respectively the point iota 1 minus iota in z plane onto the point minus iota 1 iota in w plane. So here z1 is equal to iota, z2 is equal to 1, z3 is equal to minus iota, w1 is equal to minus iota, w2 is equal to 1, w3 is equal to iota. Now we know the bilinear transformation preserve the cross ratio. So w minus w1 upon w minus w3 into w2 minus w3 upon w2 minus w1 is equal to z minus z1 upon z minus z3 into z2 minus z3 upon z2 minus z1. Now put the value of w1 w2 w3 and z1 z2 z3 in this formula. We get w plus iota upon w minus iota into 1 minus iota upon 1 plus iota is equal to z minus iota upon z plus iota 1 plus iota upon 1 minus iota. So અહીંયા આપણે w ટર્મ એક સાથે રાખીએ અને બાકીના બધા ટર્મને સામે લઈ જઈએ તો 1 plus iota આ બાજુ આવશે તો અને મલ્ટીપલમાં આવશે. So 1 plus iota into 1 plus iota 1 plus iota square and 1 minus iota ના બાજુ લઈએ તો 1 minus iota into 1 minus iota 1 minus iota whole square. So 1 plus iota square is equal to 1 plus 2 iota plus iota square. Iota square is equal to minus 1. So minus 1 plus 1 cancel out. So 2 into iota upon 1 minus iota square is equal to 1 minus 2 iota plus iota no square. Iota square is equal to minus 1. So minus 1 plus 1 cancel out. So minus 2 iota. 2 iota upon minus 2 iota. So this is cancel out and minus sign. Minus sign આની સાથે multiply કરીએ તો minus z plus iota. So we can write iota minus z upon iota plus z. Now w plus iota plus w minus iota upon w minus iota minus w plus iota is equal to iota minus z plus iota plus z upon iota plus z minus iota minus z, and this is equal to 2w upon 2I because here I cancel out, here w cancel out. So 2w upon 2 iota, 2 cancel out, અહીંયા આપને મળશે z cancel out, so 2i, અહીંયા આપને I cancel out થાય તો z plus z 2z, so z cancel out, તો આપને મળે અહીંયા w upon iota is equal to iota upon z, so iota અહીંયા multiply માં આવે તો શું થાય અહીંયા, અને અહીંયા જે આપણે મળ્યું iota iota, અહીંયા 2 iota upon 2z ને માઇનસ સાઇન, અહીંયા જે મળે છે આપણે માઇનસ આયોટા મળશે અહીંયા, so minus iota is w upon minus iota is equal to iota upon z, so w is equal to આપણે મળશે minus iota square upon z, iota square is equal to -1 અને minus sign આવે છે તો minus minus plus, this is iota square is equal to -1 minus minus plus, so w is equal to 1 upon z. Now find the bilinear transformation that map the point z1 is equal to -1, z2 is equal to 0, z3 is equal to 1 onto points w1 is equal to minus iota, w2 is equal to 1, w3 is equal to iota respectively. Also find w for z is equal to infinite, infinite કેવું 1, z tends to infinite એટલે find કરવાનું છે. તો અહીંયા આપણે z1 z2 z3 ની વેલ્યુ આપેલ છે, w1 w2 w3 ની વેલ્યુ આપેલ છે, તો ક્રોસ ફોર્મ્યુલામાં આપણે વેલ્યુ પુટ કરીએ તો w plus iota 1 minus iota 1 plus iota, z plus 1 z minus 1 0 minus 1 0 plus 1, બધી ટૂંકમાં ફોર્મ્યુલામાં વેલ્યુ મૂકી અને સિમ્પ્લિફિકેશન કરીએ આગળના એક્ઝામ્પલ પ્રમાણે વેલ્યુ સબસ્ટિટ્યુટ કરી અને સાદું રૂપ આપ્યું તો આપણને મળે w is equal to iota minus z upon iota plus z. Now w is equal to limit z tends to infinite iota minus z upon 1 plus z. તો બંનેમાંથી z કોમન લઈએ તો 1 upon z કોમન નીકળે, તો iota upon z minus 1, 1 by z common, iota by z plus 1, so 1 upon z cancel out, and z tends to infinite, 1 by z tends to 0, so this tends to 0 and this tends to 0, minus 1 upon 1 is equal to minus 1, so w is equal to minus 1. Now find the fixed point of w is equal to z plus 1 upon z. For a fixed point w is equal to z, so z is equal to z plus 1 upon z, so z into z square minus z minus 1 is equal to 0, so a is equal to 1, b is equal to minus 1, c is equal to minus 1, so z is equal to minus b plus or minus under root b square minus 4ac upon 2a, so put the value b is equal to minus 1, so minus minus plus 1 plus or minus under root 1 b square is equal to b square minus 1 square 1 minus 4, a is equal to 1, c is equal to minus 1, so minus 4 into 1 into minus 1 is equal to 4, so 1 plus 4 is equal to under root 5, so 1 plus or minus under root 5 upon 2, so z is equal to 1 plus under root 5 upon 2 and z is equal to 1 minus under root 5 upon 2. This is fixed point. Now W is equal to Z minus 1 upon Z plus 1 આપેલો હોય ત્યારે આપણે ફિક્સ પોઈન્ટ મેળવવા છે તો W is equal to Z પુટ કરવાનું. So Z is equal to Z minus 1 upon Z plus 1. So Z into Z plus 1. So Z square plus Z is equal to Z minus 1. So Z cancel out. Minus 1 is equal to I square. So Z square is equal to I square. So Z is equal to plus or minus I. This is fixed point. Thank you. Thank you.